Hello, welcome to this lesson in the Chemistry Tutor. Here we're going to do some problems involving Avogadro's law and molar volume. Now, the number one takeaway that you should remember from the last section, if you can just remember one thing, is the following. So I need you to remember this, and you're going to use this constantly throughout chemistry, okay? At standard temperature and pressure, STP, we talked about what that is. At STP, 1 mole of any gas always occupies 22.404 liters. Now, for most calculations, you can round that to 22.4 liters. So any gas, no matter what it is, if you put it at STP and just focus on looking at 1 mole of that gas, it's always going to be 22.4 liters. So now let's move into our problems, and we'll be using that fact as we move along. How many moles of nitrogen gas, N2 gas, will occupy a volume of 3.5 liters at STP? Okay, so keep in mind, whenever I tell you that at STP, 1 mole of a gas, of an ideal gas, is 22.4 liters, that's kind of behaving like a conversion factor. In other words, you can use that in your calculations because you know from your learning now that at STP, 1 mole of this gas, N2, which we're assuming for the sake of argument here is an ideal perfect gas. Of course, no gas is perfectly ideal, but it's close enough for our calculations. 1 mole of this has a volume of 22.404, like I say, liters, and most of the time you can just round that to 22.4 liters. So if 1 mole of this gas is 22.4 liters, and we know from Avogadro's law that the number of moles of a gas and its volume are directly related. If you double the gas, number of moles of the gas, you'll be doubling the volume, okay? So at STP, if 1 mole of this is 22.4 liters, then 2 moles of this gas is going to be double this amount of liters, and 3 moles of this gas will be triple this amount of liters. It's a very linear, direct relationship. So you can use this as a conversion factor, and in this problem, in fact, we're told that the volume of the gas we have at STP is 3.5 liters of nitrogen into gas. Okay, so that's what we start with. So you can just treat this as a conversion problem like we always do. And we want to find out how many moles of N2 gas we have. And we know we're at STP, so we know that 1 mole of N2 gas is 22.4 liters of N2 gas. Notice when I do my conversions, I always write down the unit and I always write down what it is I'm talking about, N2 gas, so that I know and I don't have to guess. And I write it like this instead of upside down because I want to be able to cancel liters of nitrogen gas with liters of nitrogen gas. So the only unit I have left is moles of nitrogen gas. So simply it becomes a matter of taking 3.5, multiply by 1, divide by 22.4,